Today, we're going to be writing an equation in slope-intercept form when given a table of values. Slope represents the steepness or rate of change of our line. Intercept represents the y-intercept. That tells me where the graph is going to cross the y-axis. Slope-intercept form is represented by the formula y equals mx plus b. We will need to find both the slope and the y-intercept in order to write an equation in this form. Since we've already talked about slope and y-intercept, writing these equations should be easy as 1, 2, 3. 1. First, we'll find the slope. The slope will be represented by m in the equation. 2. Next, we'll find the y-intercept. That's represented by b in our equation. Then last, 3, we'll write our equation in y equals mx plus b form. Let's try some examples together. Here, we're given a table of values and the steps 1, 2, 3 that we need to find our equation. First, we're going to need to find the slope. Let's look at our table of values. We know that slope is represented by a change in y over a change in x. I'm going to start by looking for the change of y in my table of values. To get from 15 to 10, I know that they must have subtracted 5. To move from 10 to 5, I've again moved down 5. From 5 to 0, I'm subtracting 5. And from 0 to negative 5, I'm subtracting 5. Now I'm going to look to see if I have a constant rate of change for my x values. From 0 to 1, I've added 1. From 1 to 2, I've added 1 again. From 2 to 3, and from 3 to 4. Great, we found a constant rate of change. Now we'll write this as change in y over change in x. Our change of y values was minus 5. My change in x values was plus 1. That tells me I can represent my slope by negative 5 over 1 or by negative 5, because negative 5 divided by 1 is negative 5. Now we're on to step 2. Find the y-intercept. The y-intercept is where our graph is crossing over the y-axis. When our graph crosses over the y-axis, the x value will be 0. Can you find a place on this table of values where x equals 0? Right here, x is equal to 0 when y is equal to 15. 15 is my y-intercept. That's the point on our y-axis where our graph will cross through. Now we have all the information that we need for step 3. Write your equation. Y equals mx plus b. M is represented by our slope, negative 5. Negative 5 times x plus our y-intercept, which is represented by b, is our equation. Y equals negative 5x plus 15. Let's try another one. In this next example, I've been given a table of values again. This table of values is set up horizontally. We are again going to follow our steps 1, 2, 3 in order to write an equation. Let's start with step 1. Find the slope. We know our slope is represented by change in y over a change in x. Let's look at our table of values. I like to start with the change in y. From 8 to 11, I've added 3. 11 to 14, I've added 3 again. 14 to 17, I've once again added 3. My rate of change for y is positive 3. Let's find our rate of change for x. To move from 2 to 4, I've added 2. From 4 to 6, I've added 2 again. From 6 to 8, I've added 2. I found a constant rate of change. 3 over 2, or 3/2, is my rate of change. I'm going to keep that rate of change, or slope, as a fraction. Now I can move on to step 2. I need to locate my y-intercept. I'm looking at my table of values, but I don't see a point where x equals 0. But that's okay. I'm going to use my slope or rate of change to find the value for 0 in my table. As I moved forward with my rate of change, I added 2 to my x values. If I'm going to move backwards, 2 minus 2 would bring us to 0. This is the point that we'll need in order to find our y-intercept. I'm going to do the same thing with my y values. To move forward, I was adding 3. So to move backwards, I'm going to subtract 3. 8 minus 3 equals 5. That tells me my y-intercept is y equals 5. I can use this information that I found to write my equation. Let's replace m with the slope and b with the y-intercept. I could write this equation as y equals 3 over 2x plus 5. I can use this information now to graph my equation. Today, I'm going to show you how to check by graphing your equation. After I graph this equation up here on my coordinate grid, I can check to see that the other points fall on the line. I've gone ahead and graphed my y-intercept on the line, and then I've moved and plotted more points by using my slope, my rise over run. I've moved up 3 over 2, up 3 over 2. Here's my y-intercept. My y-intercept was 0, 5. Now I can check to make sure this graph is accurate by seeing if these other points from my table of values are on the same line. Let's look for this point, 2, 8. 2, 8. I found that point and it falls on my line. The next point is 4, 11. 4, 11. Here's the next point. Again, it's on my line. I could keep using this method to check that my graphing was accurate. Now you're going to try writing an equation in slope-intercept form. Remember the 1, 2, 3 steps. First, find the slope. Next, identify the y-intercept when x is equal to 0. Last, write your equation in y equals mx plus b form. You can check your work by graphing your equation and checking to see that the points from your table fall on the line that you graphed. Good luck!